In this problem, we're given the cumulative probability distribution, and we're asked to work out what is the corresponding probability density function, and we're also asked to calculate the probability for this random variable to take on a value between 1 and 2. What is the expectation and variance of this random variable? So let's do this one at a time. The corresponding probability density function, well, given that the cumulative probability distribution is the integral of the probability density function, then it should be clear that the probability density function is just a derivative of the cumulative. So for x less than 0, the derivative is 0. For x greater than 2, the derivative is also 0. And for x between 0 and 2, the PDF is simply 1/2 times x. So next we're asked, what is the probability for x to be in the range from 1 to 2? Well, if we know the probability density, we could work it out from there. So working out the probability for the random variable to take on a range from, to be within the range from 1 to 2 would just be the integral of the probability density function between those two limits. But of course we could also just use the probability, cumulative probability distribution itself, essentially looking at, this is the difference between this integral from 2 and the integral from 1. So this is probably the easiest way to work out the problem. We did not need to know what the probability density function is. So here we have 1 minus 1/4. So we can see the probability for x to be in the range 1 to 2 is 3/4. Now that would be the same result if you integrated the probability density function. Next we're asked what's the expectation and variance of the random variable capital X. So the expectation value is found by integrating over the entire range x times the probability density function of x. And so for this, we certainly do need the probability density. So we're integrating from 0 to 2, 1/2 x squared, giving us 1/6 x cubed from 0 to 2, which is 8 over 6, or 4/3. Now to calculate the variance, we need to know the expectation value of x squared. So we're integrating from 0 to 2, 1/2 times x cubed. And that gives us 1/8 times x to the 4th, so evaluated from 2 to 0. So that would be 16 over 8, or 2. So finally, the variance of x being equal to the expectation of x squared minus the expectation of x squared. This is 2 minus 16 over 9. So that's 18/9. So that's 2 over 9. So the variance is 2/9.